So here we are with Unit 2.21, and we're going to be looking at polynomial identities. That may kind of sound like Chinese right now, but it's really just saying we're looking at different ways to write out polynomials, and we're going to find that they can be very, very helpful. Particularly when you move into calculus, knowing these identities can help you manipulate polynomials in a way that can be just make things so much easier. So this is kind of where we're starting with that. Think about these three questions. So take your time, go ahead and pause the video right now, write these down, and answer each part, A, B, and C, and then when you're done, come back and we'll talk. Alright, so hopefully that went well. Let's just sort of go through it step by step, and we'll notice that we're building up to something which is a lot more powerful than what we started with. So if we just write down a set of three consecutive integers starting with 2, well, we're going to start with 2, obviously, and then what comes next? Well, 3, and then 4. Really not too hard, pretty simple. And what we want to do is we want to take that one step further. So now we want to write those same numbers, but we want to write each one as 2 plus another number. So let's just think about it. So let's start with the first one. We have 2. And what do we add to 2? Well, we don't have to add anything. That's just 2. And then we have 3. Well, 3 is 2 plus 1. Okay. And then the number that comes after that, 4, is going to be 2 plus 2. Okay. That's interesting. But the reason we do that is so we can see the structure that's happening. If you want to write 3 consecutive integers starting with 2, well, the one that comes after 2 is going to be 2 plus 1, and the one that comes after that one is going to be 2 plus 1 plus 1, or 2 plus 2. So now, instead of starting at 2, we want to be able to start at any integer, and we'll call this any integer n. So in other words, it's a variable that represents any integer you want to start with. And we want to write 3 consecutive integers in terms of n. And so the idea here is that we take what we've done in A and B and apply it as if we can start with any integer. So if we start with n, what's the first integer going to be? Simple enough. All right, we start with n, the first integer is n. Well, what comes after n? Think back to when we started with 2. The value that comes after 2 is 2 plus 1. Similarly here, when we start with n, the value that comes after n will be n plus 1. And I bet by now you've figured it out. After n plus 1, well, I add 1 to it to get my next consecutive integer, and so that'll be n plus 1 plus 1, or n plus 2, right? It is 2 numbers after n. Okay? So keep this in the back of our mind. What we've done here is we've said, let's write something. This represents 3 integers no matter where I want to start, right? So if I want to start at 100, I can represent starting at 100 by thinking about 100, 100 plus 1, and then 100 plus 2. Okay, and this will come back to be helpful. The last thing to note is how much more variance there is here, right? If I just say write 3 consecutive integers, starting with 2, there's only one possibility here. But here, any set of 3 consecutive integers can be represented. And that's important, and we'll see why coming up. So here's our first identity. We're going to be looking at a pattern, and you'll start to understand what I mean by identity after we've looked at this first one. So take a second, go ahead and copy all of this down, and you're going to want to spend 3 minutes at least on your own answering these questions. So will the pattern work? So on and so forth. What I want you to do on your paper is I want you to go ahead and split it up in half, and on the left side I want you to write down your answers and all the work that you do on your own as you go through, and on the right side you can have all of the notes that we do here. Okay, so that's what I'll be looking for. So take your time, 3 minutes, and then go ahead and press play again, and we'll talk about it. Alright, so we're noticing a pattern here where when we have consecutive integers and then we take the difference of the squares of those integers, we notice that we're getting odd numbers every time. So the first 2 integers, 0 and 1, I square 1, I square 0, I subtract the 2, I get 1. Go down the list, and I keep noticing that when I do that, the answer that I get is odd. And I do that all the way until I get to 4 and 5, and then I wonder to myself, will this pattern work for any pair of consecutive integers? And so I'm wondering, what you did. You probably tried a couple, right? Maybe you tried something random like 12 and 13, or maybe you tried 100 and 101. And if you did, you found that the answer you got was odd. But are you sure that this works for any set of integers? And to be completely sure, what would you have to do in order to be 100,000% certain? Well, in order to do that, you'd have to try out every single pair of consecutive integers. And so I'd ask you, how long will that take you? And your answer would be infinitely long. You'd be here forever. And that's not fun. We want to be able to prove this. We want to be able to be completely sure that it will work for any set of consecutive integers, and we don't want to spend forever doing it. So I want you to pause the video again and think about how could you show that this will be true for any set of consecutive integers, no matter what they are. So in thinking about how we could prove that this is true for anything, you might have thought, well, what if we could, instead of just going and using the actual examples, 4 and 5, 5 and 6, so on and so forth, we could represent each number with variables, meaning that we could say, if you go think back to what we just talked about, if instead of just taking 3 consecutive numbers starting with 2, we could write them in terms of a variable so that that variable could represent any number. Okay, so if we started at 1,000, then that's fine. Our variables would start with 1,000, and then the next number would be 1,001. And so what we're going to do first is we're going to try and write the relationship in terms of the variable. And in this case, we're going to use the variable n. So pause the video again, and our goal is going to be to write this pattern in terms of n. Okay, so in general, what I'm actually talking about, we're not going to deal with the right side yet. Let's just try and write the left side, what's happening on the left side, in terms of n. So go ahead and pause the video and try that out. Alright, so just a reminder, I'm going to be looking at the left side of your paper to see what you tried, and now we're going to talk about it. So let's start at the very beginning. What integers are we dealing with? We're not just dealing with any random integers. We're dealing with an integer and then the one that comes right after it. So let's think about that. We have the first integer, and we're going to subtract that first integer squared from the second integer, or the larger integer. So let's say, just think about it. If we started at 0, if that was our integer, what would we do to get the larger integer? Well, if you just look at the pattern here, if I started with 1 as my first integer, my next integer is 1 plus 1. If I started with 2, my next integer is 2 plus 1. So if I want to represent this in terms of n being any integer I could ever think of, if this were n, the number over here that I'm subtracting that from is n plus 1. Okay? And now we just think about what are we doing with n and n plus 1, right? This is some integer, it's completely random, it doesn't matter what it is, and then this is the number that comes right after it. And what we're going to do is we're going to square both of them and then subtract the smaller n squared from the larger n squared, or n plus 1 squared minus n squared. Okay? And we want to think about, what do we want that to be equal to? And you might be saying to yourself, well, I just want it to be odd. Okay, let's just start with that. We want it to be odd. Okay, we want it to be some sort of odd number. So we'll just keep it like that for a second, and now we want to pause and think about what is our goal to show. So pause the video and think about, at this point, what are we going to try and show? Alright, so hopefully you're realizing that our goal, in order to prove that no matter what integer we choose, consecutive integers, and then subtracting them will give me an odd number, I have to show that the left side of my equation is always equal to the right side. Okay? And so in this case, I've got to show that this over here is always going to be odd. Okay? And I'm purposefully going to leave this as odd for now because we're going to talk about how to represent an odd number in just a second. So what are we going to do in order to show that it's odd? Well, what we want to do is we want to try and manipulate this equation, this situation here, so that the left side looks just like the right side. But we can't just turn this expression into the letters ODD. That is not going to work. So we need to think about what is an odd number going to look like. And what I want you to do is just pause the video and think about, what does an odd number look like? What are its characteristics? Hopefully, in thinking about that, you thought about how an odd number is always one more than an even number. So what makes up an even number? Well, let's just think about all of the integers. So if we just started 0, 1, 2, 3, 4, right? These are all, if we just cycle through these, what are the even numbers? And we don't even have to consider 0. 0 is neither even nor odd. So let's just kind of pretend that, that we're starting with 1, okay? So if we start with 1, if that's our integer n, then what would we have to do to n in order to make it even? Well, the first even number is 2, so we'd have to multiply it by 2. Okay, then think about the next integer. If 2 was our integer n, what would we have to do to make that the next even number? Well, we'd have to multiply it again by 2, right? Because that would give us 4. If 3 were our integer, what would we have to do to turn that into the next even number? We'd have to multiply by 2, right? 2, 4, 6. 8, 2 times 4. So notice that an even number is always 2 times any integer. All the even numbers can be written as 2 times any integer, right? So you take any integer, you double it, that's an even number. And you can cycle through all of the even numbers just by taking every number and doubling it, right? So 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, 2 times 5 is 10. Now think about the even numbers, 2, 4, 6, 8, 10, so on and so forth. Now, how would we make these odd? Remember how we said that an odd number is always one more than an even number? So think about it this way. If you started with 1, okay, 2 times 1 is 2, right? Now when I add 1 to that, I'm going to end up with 3. Okay, so 2n, up here. So if I have 2 times 1, that'll be 2, and then I can add 1 to it, and that'll be 3. Okay? Now imagine I started with 0. If I had started with 0, if 0 is my first number, 2 times 0 is 0, and if I add 1 to that, I would get 1. Okay? Another way we could represent it is we could almost think of just subtracting 1. It all sort of depends on where you want to start. But let's just go with 2 plus 1. So if we were to start with 0, 2 times n, 2 times 0 is 0, add 1, we get 1. When we get to 1, 2 times 1 is 2, add 1, we get 3. If I go to 2, 2 times 2 is 4, add 1, I get 5. Those are all the odd numbers. So I can represent the odd numbers as 2 times any integer plus 1. Okay? And be careful here. When I say n, okay, I'm not actually talking about the same n here. Okay? So maybe I should actually erase that. And an odd number is just any situation where I have 2 times a number, we'll just call it a number, plus 1. So if I have 2 times any integer, and then I add 1 to it, it'll be odd. And so what I'm looking for is I'm looking to create a situation where my left side looks like 2 times a number plus 1. And if I can get this into 2 times a number plus 1, I know it will have to be odd. So go ahead and pause now. Go ahead and try doing that yourself, and then we'll come back and take a look. All right, so hopefully that went well. We're going to get much better at this as time goes along. So in order to start simplifying this, it's always helpful to square out what you can square. So n plus 1 squared is n plus 1 times n plus 1. And if I FOIL that out, I'm going to get n squared plus 2n plus 1. And then I have still minus n squared. And so now, if I look at the left side of my equation, there's some common terms, some like terms that I can combine. Notice I have an n squared and a negative n squared. So n squared minus n squared, those cancel. There's 0. N squared minus n squared is 0, so I'm left with 2n plus 1. 2 times my first integer plus 1. But remember that 2n plus 1 is always odd because 2 times some number plus 1 is always odd. And so what we've done is we've shown that no matter what integer you choose, that integer and then the integer after it squared and taking the difference of those two will always end up being an odd number. Okay? So what I want you to do is pause. I want you to go ahead and write out in your own words what you've just shown. Okay? If you don't remember what I said, that's totally fine. Don't rewind. Try doing it yourself, and then move on to the next page. Here are some questions that I want you to try, 1, 2, and 3. Write them down. Try them to the best of your ability. Write in any questions that you have or things that you're confused by, and come prepared tomorrow with questions.